Well services personnel are exposed to many hazards as we go through our daily routines. How we identify and control these hazards determines the level of risk we might take. We all understand that driving is by far the biggest hazard we are challenged with in Schlumberger, but there are others that when not controlled can have disastrous effects. Today we want to look more at the hazard of pressure. We tend to think that this hazard only exposes itself at the well site. However, there are many other activities performed where pressure is a real hazard. We must always be aware of the situation around us, the potential for pressure to exist, and the consequences of a sudden unplanned release. Take our laboratories for example. Most people would consider that the main hazard in the lab would be exposure to dangerous chemicals. However, much of the equipment used in the lab to perform the different tests runs under high pressure conditions. We do specify controls such as shielding, high pressure rooms, and warning signs. So be aware of these and do not enter any lab unless you're fully aware of the processes or you are accompanied by an experienced person. Maintenance operations, whether conducted in the workshop or out on location, is another task that often exposes employees to the hazard of pressure. Working on hydraulic and pneumatic systems requires knowledge. This includes understanding the functions of these systems and where the danger might be if the work is carried out in the wrong sequence. Trap pressure is a serious cause for concern in maintenance. Due to the often restricted workspaces this work is performed in, there are secondary hazards which can result from a sudden movement by the employee. Always consider these in the HARC when planning the work. But of course, the main exposure to pressure is to those employees in the field working around the client's wellhead and our high pressure lines and pumps. In the late 70s, early 80s, Schlumberger Well Services, or Dow Schlumberger as we were known then, understood the risk of working with pressure. To that effect, 2 videos were made to show the results of uncontrolled release of both low and high pressure. I am sure many of you remember Don't Tease the Tiger. This was made in the Algerian desert to show employees the danger of dealing with large volumes of what we might call low pressure. For example, 15 to 40 psi. As you may recall, cement silos were overpressured to show us what can happen if and when the pressure increases to such an extent it is more than the vessel can safely contain. It does not take long for the hazard to be realized. Can you imagine the devastation this could cause if this happened during an actual job? Of course, today we have strict procurement controls and thorough inspections programs on all types of bulk tanks to ensure they are purchased and remain in good condition. We also ensure that each tank has a pressure relief valve. However, it is vitally important at the location that these inspections are completed properly and that all PRVs are tested and certified in accordance with this standard. With these controls in place, the likelihood of a silo failing in this fashion is extremely low. However, there was a second incident in this video. This incident could happen today to any one of us if we do not take care and follow the proper procedures when working on pressure-containing equipment. Let's remind ourselves what happened. Here we can see the operator starting to open the inspection hatch on the bottom of a silo. He believes that all the pressure has been bled off. However, as we know now, this was not the case. In fact, we know there is around 4 psi of pressure in the tank. 4 psi would certainly not be considered high pressure. So does it really matter? That low pressure acting on the large area of the hatch cover is huge. The cover flew off and severely injured the employee. Look at the mannequin. We certainly do not want to repeat that. On reviewing Quest, we see many examples of personnel being exposed to trap pressure. We need to remember this every time we approach any pressure-containing equipment. There is always the potential that the equipment may contain trap pressure, and we must deal with it accordingly. Simply looking at gauges or opening valves is not enough. Gauges can malfunction and valves can become plugged. Always make sure you check thoroughly for trap pressure, and even then, make sure you open anything in such a manner that if it were to be pressurized, it cannot harm you. This is an example of how low pressure can be a danger to all of us, and of course, high pressure has the exact same risk. I am sure you all recall the video There Are No Clowns, where we purposely failed a high pressure line at a very high pressure with an energized fluid. The devastation that was caused to the mannequins and the distance the heavy iron was thrown through the air was quite frightening. Let's take a moment to familiarize ourselves with this picture. That's quite amazing to see high pressure iron failing and the results that the failure can have. Let's watch again in slow motion. Of course, we must remind ourselves that this was a demonstration. The line was purposely weakened to allow the failure to occur. But could that happen to us today? Well, let's think about that. We limit the suppliers to only those we know can deliver treating equipment to our very strict design criteria. We have a very thorough inspection process to ensure we identify any deterioration or weak points in the iron on a regular basis. We use competent people and proven inspection procedures to ensure that the iron we have in the field is in good condition. So, we purchase good quality treating equipment and we maintain it as per our standards. But what other safety devices do we have to prevent that same iron from being exposed to pressure above what it is designed for? In all our pumps, we have installed overpressure shutdowns. When working correctly, the overpressure shutdown is a good system for controlling pressure. The key here, of course, is the human factor. We must ensure that the overpressure shutdown system is functioning and that it is set properly prior to each operation. But of course, there are certain conditions when the overpressure shutdown system does not have the time to activate. In these situations, we are still protected, however, as we have mandated the need for burst discs to be installed in all of our high-pressure pumps. When ruptured, the burst disc will perform its function and prevent a failure to either the pump or to the treating equipment. Finally, in many operations and locations, we have a further safety device, a pressure relief valve or PRV. These devices are generally placed into the high-pressure line and are designed to relieve at a predetermined pressure. For PRVs to function properly, it is mandatory that they are maintained and operated by personnel who are competent to perform these tasks. These processes and procedures no doubt greatly improve our safety on location. Each of these on their own and of course together will greatly reduce the possibility of a line failure while performing a job. However, we all know treating iron accidents still occur, and regardless of what we do in the future, we can never completely remove the potential for an accident to happen. Even with our controls, since 2006 we have had on average 10 iron failures per year. This means we have had situations where the iron in the line has parted and there has been an uncontrolled release of fluids. Fortunately, in these occasions there were no personnel in the area of the failure. However, in 2009 we suffered 2 fatalities, and in 2010 we injured another employee directly related to pressure events. In Russia, a contractor working with our crews was killed when the line he was pumping into was blocked by an ice plug. That ice plug then gave way, causing the line to jump and hit the contractor on the head. This resulted in an immediate fatal wound. In Bakersfield in 2010, an employee working on a coiled tubing job was injured when the line he was bleeding off swung round and impacted his arm. Why don't we let him tell you about it?
The rest of the guys were taking down the fluid and iron off, and the iron for the nitrogen was still rigged up, of course. And normally when you rig down, you start from the pump to the wellhead, which will be the pump to the coiled tubing. And I believe they were about done because the last piece would have been that Chixon that actually ended up hitting my arm. When I went over to try to close that valve so we could finish rigging down, I just remember going up there and trying to put on one side. He said, well, you know what, babe, better handle in right in the middle right here. And I just remember really pushing.
Jacinto obviously was very lucky. Although he did suffer some significant injury, he is here today to tell us his story. However, in Denmark in 2009, a nitrogen contractor working for us was not so lucky. During a pressure test with nitrogen, the overpressure relief valve unexpectedly relieved pressure. As it relieved, it rotated on the line and fell towards the deck. The nitrogen operator was in the path of the valve and it hit him on the forehead, resulting in a fatal injury. No matter what inspections or safety devices we put in place, there is always a risk that equipment under pressure may act in an unexpected manner. As we improve inspections processes, develop better and more reliable safety devices, write stronger procedures, and train our people on them, we can never completely remove the risk. There is one thing we can do, though, and that is to make sure our people are not exposed to unacceptable pressure, such as being in the high-pressure area while a high-pressure test is being performed, or working on or around equipment which is under pressure. In the Denmark accident, this event would have happened, but had the area been cleared of personnel, the operator would not have been in the danger zone and would not have been impacted by the valve. So please remember, always make sure your equipment is maintained and certified in accordance with the standards, especially pressure-containing equipment. Make sure your gauges and safety devices are functioning and working before every operation. Always assume there could be trap pressure in the system and approach it accordingly. And finally, when pressure testing lines and equipment, ensure all personnel are in the safe zone. We do not want to have anyone walking around this area should this type of failure occur. Remember, it's you who can make the difference. You must ensure that all your equipment is current on its certification prior to use. You must ensure that all safety devices are in place, and where required that they have been function tested prior to the job. You must approach all equipment assuming there may be trap pressure and interact with it accordingly. You must ensure you never enter the high pressure area while under pressure, and at other times only when expressly instructed to do so by the job supervisor. If you remember to do all this, then we shall all be going home at night.